Let's see if we can use our kinematics equations to solve a word problem. Here we have a student who rides a skateboard at a speed of 12 meters per second, and she slows down for 3.1 seconds at an acceleration of negative 2.5 meters per second squared. What I want to know is how far did she travel? I see that I have an initial velocity of 12 meters per second. I have a time, or it's a delta t if we want to look at it that way, but I'm going to call it a time of 3.1 seconds. And we have an acceleration of negative 2.5 meters per second squared. Now let's be very careful what this negative means. We have a negative acceleration, and what that means is that we are slowing down. When it's a positive, it speeds up. So a negative acceleration means that we are getting slower, and a positive acceleration means that we're getting faster. What we're trying to figure out in this problem is what is the total distance traveled while the skateboarder is slowing down. We'll see that we had a distance formula from the first equation that included or utilized the two velocities. The problem we have with this word problem is that we don't have a second velocity. So we can't use this equation. And when we look at our second kinematic equation, we'll notice that there's no distance formula used. So what we're going to need to do for this problem is we're going to have to combine these two formulas to make it work for us. So what I'm going to do is I'm going to take my first kinematic equation. My distance is my first velocity, my initial velocity. And instead of putting my VF, I'm just going to put in what VF is from the second kinematic equation. That entire thing gets divided by 2 and multiplied by t. So we're going to combine some like terms here. I see we got 2 VIs, and we have an AT. We're going to divide this by 2 and multiply it by t. I'm going to multiply it by t first. I'm going to end up with 2 initial velocities multiplied by t plus a t squared divided by 2. So we have that the distance or displacement, and we're going to divide both the variables here by 2. So this is going to be 2 divided by 2 VIT plus 1 AT squared divided by 2. So we're going to end up with this new kinematic 3 equation for displacement. And I'm not going to write 2 over 2. That's just 1. So the initial velocity times time plus half of AT squared, or you might just say AT squared divided by 2, whichever works best for you. This is our third kinematic equation. These are good formulas to memorize so that we don't have to derive them every time we're solving a problem. Given. So we can find that the distance or displacement is equal to the initial velocity. In this case, it was 12 meters per second multiplied by the time, which was 3.1 seconds. Then what we'll do is we'll take half of the acceleration, which was, remember, it was a negative, I'm going to put that in brackets, negative 2.5 meters per second squared, multiplied by t squared, which is 3.1 seconds squared. Going to be very careful to watch our units. What we'll have is we'll have an initial, or the displacement that we're trying to find, will be equal to 12 times 3.1, which is 37.2 meters, plus, and let's see, half of 2.5, and it's 3.1 squared. This is going to give me 12.0125. And when I look at the units, I see seconds squared on top. I see seconds squared on the bottom. So these seconds squared and these seconds squared will cancel, and I'm left with meters, which is fantastic. We need to check our units. We got meters plus meters, which is good. So our distance is going to be 37. Oh, that's a negative. 37.2 take away 12.0125. I'm going to do this to the proper significant digits, and we're going to end up with 25 meters. That's how far our skateboarder went while her skateboard slowed down. Using algebra skills to rearrange this equation. And some of them are a little easier than equations. Let's say we wanted to find VI. I'm going to start by taking the 1/2 AT squared to the other side of the equation. And then if I divide both sides of the equation by t, I will have the initial velocity is equal to d divided by t, and the negative 1/2 AT squared is also divided by t. And we should see that that can simplify a little bit. So it's distance divided by time, subtract a times time divided by 2, or 1/2 AT. Velocity is equal to d minus AT squared over 2t. Let's say we're trying to figure out what our initial velocity was, but we travel for 2 seconds, we accelerate at 4 meters per second squared, and we traveled a distance of 100 meters in that time. So using our formula, where we know the initial velocity equals the distance, take away AT squared, all divided by 2t. And all we do is we substitute our variables into this equation. So our initial velocity will be equal to 100 meters, subtract 4 meters per second squared, multiplied by our time of 2 seconds squared, divided by 2 times our time, which once again was 2 seconds. What we're going to have now is we work through the algebra. Our initial velocity is equal to 100 meters. Take away 4 times 2 squared, which is 16. You'll notice that here I have, once again, meters divided by second squared, multiplied by second squared. So the second squares are going to cancel each other out. And on the bottom, we're going to have 2 times 2 seconds, which is 4 seconds. So our initial velocity will be 84 meters divided by 4 seconds. So the initial velocity will be 21 meters per second. Acceleration. A little bit of algebra. This time, I'm going to start with my equation. I'm going to subtract the VIT from both sides, and that's going to give me 1/2 AT squared. I think I'm going to get rid of this half by multiplying everything by 2. So I'm going to get 2D take away 2 VIT equals AT squared. So I'll have 2D take away 2 VIT all divided by t squared equals the acceleration. Be very cautious when you have the initial velocity of 0. Many students miss this. When you have an initial velocity of 0 meters per second, it's a special case where we're not actually moving. It actually makes your equation much easier. We'll find that the acceleration is simply 2 times the distance, subtract 0 over t squared, or the acceleration is 2d over time squared. The equation is possibly the most difficult. It has the easiest algebra in some senses, but the mathematics to solve it are a little more challenging. I'm going to move d to the opposite side of the equation, and so what we'll end up with is a 0 over here, and VIT plus 1/2 AT squared subtract d. And I'm going to reorganize this a little bit so that we have 0 equals, and I'm going to put the t squareds at front, followed by the single t's minus d. I don't like having the fractions. Many students don't. So I'm going to multiply everything by 2. So I'm going to end up with 0 is at squared plus 2vit, take away 2d. Parabolic function. Some of the common ways you learn how to solve that in Math 11. Method 1 might be through factoring. A second method might be through the quadratic equation. And the third method might be from graphing and finding our x-intercepts, or commonly referred to as roots. So let's use that equation to solve some kind of problem. So here we have the acceleration of 4 meters per second squared. The initial velocity is 6 meters per second, and the distance traveled was 2 meters. And I want to know how long was the time in seconds to do this. So once again, we had our equation, which was at squared plus 2 times the initial velocity multiplied by t, subtract 2 times the distance equals 0. So our acceleration in this example was 4. I'm just going to leave the units out just for the ease of the video. This is going to be 4t squared plus 2 times the velocity, which was 6, multiplied by t, subtract 2 times the distance. The distance in this question was 2. So we have 4t squared plus 12t minus 4 equals 0. So now we can use quadratic equation. We can graph it, or we can try to factor it. In fact, that one's not that hard to factor. Let's say I've got a t squared plus 3t minus 1 equals 0. I've reduced it, but I don't think I can get it any further than that. So I'm going to use my graphing calculator to solve this. But from my graphing calculator, I found that there's 2 answers. I found that t can either be negative 3.30 seconds, or that the time t can be 0.30 seconds. Well, I know that it's impossible for us to have negative amount of time, so I'm going to use the positive answer, 0.3 seconds, as my answer.